The extreme value theorem says that if you have a continuous function and you have a closed interval, meaning you have brackets like we do here, 3 and 9, and they have brackets around them, so it's a closed interval. If you have a closed interval and a continuous function, then there is a maximum and a minimum on this interval. Okay? So with this one, it's a closed interval. Now, is it continuous between x equals 3 and x equals 9? We should check those endpoints. If you plug in 3, it's going to be natural log 3 minus 12. That makes negative 9. Can you take e and raise it to some power to make it equal negative 9? What's the value for x that would make that happen? You can't, right? An exponent doesn't change a number from positive to negative. So this one is no, and the reason is because it's not continuous on this interval. So for this function, we need it to be continuous on this interval. So the one tricky part might be the 3/2. If we this is x minus 2 squared over the square root of x minus 2. That's how you could rewrite this. So one thing we want to be looking out for is that x has to be greater than 2 for it to be continuous. Oh, and we got a problem right here, right? Because at x equals 1, this isn't going to be defined down here. 1 minus 2 is negative 1. So same thing for this one. No, because it's not continuous for all values. It doesn't even exist at x equals 1. Okay, so we got this function. Does the extreme value theorem guarantee the existence of an absolute minimum and maximum on this interval? And then we said the two requirements are that it's continuous and that wow, I forgot. Closed interval, right? Can't have parentheses here. It's got to be a closed interval. So continuous in a closed interval. If you've looked at e to the x before, or any sort of function, exponential function like this, you'll see it looks something like this. For all values of x, it's defined. Okay. The question might be if this exponent does anything weird. You can have a negative exponent on in a function like this, and that's okay. So there's no problems with taking the square root of a negative. There's no divide by 0 problems. This thing is continuous everywhere, and it's a closed interval. So does the extreme value theorem guarantee an absolute minimum and an absolute maximum? Yes, it does, because it meets those two criteria.